Okay, shall I start?
Yes.
Well, let me start by describing how, say, in the last couple of years, I think that catalysis did, for instance, in Europe, but is more specific in Holland. Holland, of course, has always been very heavily interested in catalysis and was, at least for such a small country, quite strong in catalysis. But most of the catalysis has been related to the oil industry and to the petrochemical industry, and of course that is not so strange if you think about the strong positions of the big companies like Shell. They had their main laboratory in Amsterdam, or still have it. Unilever, Akzo, catalyst manufacturer too, in Holland. So in that sense, we are very related to other Western countries, and all over the world. I think you see a trend now to sort of slow down in the amount of research in this field, in the oil and petrochemical field, and I think you can see that in Holland too. Of course, it's my opinion that most of the big discoveries, really great breakthroughs, have been made in that field. Well, there will always be new breakthroughs, but you can't expect this to go on like it has been in the past decades, and at least in say in the last 2 decades, it has already slowed down. And on top of that, the industry itself is, of course, very mature, and so I foresee, not immediately, but say in the somewhat longer run, let's say in 1 or 2 decades, that maybe part of this industry, at least the oil industry, will go into the direction what I think let's say the steel industry has gone. A very mature industry which knows what it's doing mainly, and still needs research, but not that much as it used to need. And on top of that, of course, we see a shift in opportunities. For instance, the Arabs will take over gradually the more heavy part of the industry, and then there is and was a slowdown of the economy, and all that. When you really add all that together, I think there's less and less opportunity, and I don't see in the first decade that there will be a reversal in that trend. So I've come to the opinion that the oil industry will look for certain things in the good old fields, but most of the real, say, breakthroughs from a chemical or from a chemical engineering point of view, we have them already. So, and that means that you either come to the conclusion that the field is going to slowly die away to a somewhat lower level. It will never die away to a zero level, but, well, to a lower level, unless there's new opportunities in other fields. Well, I think one of the other fields, and people have been talking about, in that sense it's not a unique view that I can offer here, is in the specialty chemicals and in the fine chemicals area. And of course many countries have been talking about it and are doing something about it, and also in Holland we are trying to do something about it and talking about programs, and I heard also other countries. Now, one of the problems there is that this is, of course, a completely new type of application, and so it will be difficult to make a change, and also because the difficulty is, in my mind, in the type of organic chemistry that we are now relating to. Because in the past, in the oil type of or petrochemical type of application, it was very difficult, and therefore we could do very nice work. But on the other hand, it was easy if you compare it to organic chemistry if we are going into the fine chemicals area. For instance, you can divide catalysis or catalyst broadly into a couple of areas. Like sometimes take the book of Gates and Ketzer and Schuit. They divide it in 5 areas, like oxides, sulfide, metals, homogeneous type of things, and what was the other one? Oh, the acids, yeah. I think that sort of broadly covers the whole area, and the nice thing about it is that you have a broad class and you have just a few classes, and by studying a class, say in the academic world, you can still have quite an impact. For instance, take acids. By studying carbenium ion chemistry, you can apply it and you can just study this class of reactions. However, when we now jump to another type of application, like say in the organics, I think one of the big problems will be that it's very difficult to come up with general ideas, and that means that much more than in the past, also in academia, we will be faced with the problem which the industry has faced always, of course, and that is to relate to what we want to make and what we want to take in as a reactant. And I think that's one of the challenges, and if we are not going to face up to that, I think then indeed there isn't that much a great future for catalysis. But it also means that we have to switch. We have to pay much more attention than to organic chemistry, and where you have to relate to the organic chemist, which over the past decade we haven't done that well. When you really think about it, how much organic catalysis is done, it isn't that much. Most of course, there's quite a bit of characterization and reactions, but it looks like more and more characterization in the last years, maybe because there aren't too many new reactions, so people are concentrating more on the characterization. So one of the challenges then, at least that's how I see it, and that's where I want to do some research myself actually, I want to switch to such a field, is then to find classes of reaction, because in the long run it's not very useful to just study one component and to transfer it to make something else, to transfer it into something else and show A to B and then take A very general and B very general, because then you can never apply it to another reaction, and unless you are very lucky. But so the problem will be looking for classes of compounds, turning them to other classes of compounds, and get a guidance there from the organic chemist and interact with them. And maybe then by doing that we will need more of the organometallic chemist and organometallic chemistry, and so maybe that field will then finally find some use too, because over the past decade or so, and maybe even longer, we have, or they have, talked quite a bit about organometallics and being so useful and then having an impact, but if you really think about it, it hasn't had that great an impact. There are a few beautiful examples of homogeneous catalysis or homogeneous catalyst turned heterogeneous, and of course even the heterogeneous catalysis owes quite a bit to the field of homogeneous, in the sense that of course our ideas are very influenced by their way of thinking. But I think there is an enormous wealth of chemistry in that field, which if you look now, say in organic departments, some of them are now taking up the challenge and are taking in quite a few organometallic chemists, which up to now has mainly been the area of the inorganic chemistry. So you see that the organometallics is making inroads in organic chemistry now, and so there you could have quite a bridge, say between the more inorganic type of catalysis, the heterogeneous catalysis, and the organic chemistry, and then the organometallics in the middle, in between. And so yes, I think there are quite a few challenges on the academic side, and of course this will be an interaction with the industry, and it will be difficult to you can't expect the industry to suddenly jump everybody on that kind of a bandwagon, and because then the prices will plummet like hell, and then of course there will be no market for anybody. So it will never be the way it was for the oil companies, but then the oil companies never, and the petrochemical companies never really spent that much on research. If you think about it, they were big companies, but with the few percent of money of their turnover they spend on research, well, if you multiply that, it's still substantial. However, the pharmaceutical companies are much smaller. On the other hand, they spend much more on research. So if you do that kind of a multiplication, still there are quite a few jobs for the most of us, or better say, probably our successors. So I think that yeah, there are challenges, but the field will gradually change. We will still be talking about, say, the good old subjects, which will develop more and more, and eventually will be fully developed, coming from the oil and petrochemical area. But we'll have to develop, and we will develop new kind of chemistries, catalytic chemistries, and that has to be in fields like fine chemicals, pharmaceuticals, and the like. And making now a jump back to the beginning of my story. The reason why I also think that, say, in the petrochemicals and in the oil field there will be not too many breakthroughs. That is, that because we over the past say in this century we catalysts have been, of course, influenced by many others, and of course by ourselves, but the real big influences have been like inorganic chemistry, the solid state structures and so on, say, the big theories there in the 20s and in the 30s, and so before the Second World War, and after the World War, that was applied, say, in catalysis, solid state chemistry in general, and also then theories about metals and so on, and that has been fully developed in catalysis together with the full development of solid state physics after the war, and we have seen all the influences. Organometallics after it started, say, the big start, of course, was somewhere after the war. That has had its influence, but it has slowed down. But I think there are more opportunities there than really ever developed out of that promise. Now lately, say over the last decade, we have of course seen the maturing of techniques, especially surface science. Before that, of course, many spectroscopic techniques already were entering our field, but now especially lately it's the surface science, and that has had quite an impact and has extremely broadened our views. But on the other hand, it has given us a much better view of what's going on, but it hasn't up to now really made great big breakthroughs. I think the real breakthroughs will ever be there whenever there is a combination of new chemistry and exciting new things. So at the moment it looks like in the petrochemicals and an oil field there aren't that many breakthroughs to be waiting for, and so if catalysis has to go on the present level of that it is doing, and has to stay healthy, then it has to look, and it will look, for other applications. So that is then, in my mind, is the fine chemicals and the like. And there will be many opportunities there, and we'll have to face that challenge. Not only being, say, in catalysis now and getting too old to leave the field and jump on something else, but also, say, for the Western world, because if you really think about it, of course, the added value in the petrochemicals and in the oil field isn't that much, and it will be taken away from us. So again, like I already said, I foresee that especially the oil side of it, all of it, is going like the steel industry, a mature industry. We need it, but as far as from a research point of view, and that's the point I'm taking, because as a professor I'm interested in what the industry needs and where my students can go. I think they will need a few, but less than they did, and the signs are on the wall, and more than that.